Thanks, Larry. Right, good. Yeah, so Song Fu, Professor Song Fu has been gracious to let us come and speak to us today. He's been at UNT for 13 years now, and back in March, he won a National Science Foundation Award for the Center for Electric, Connected, and Autonomous Technologies for Mobility, or it's eCAT for short, eCAT. The key areas of eCAT are mobility technologies, connected vehicles, autonomous vehicles, edge and cloud computing, electrification, and artificial intelligence. And he's going to give us more insight into all of this thing. The center's strategic directions are connected autonomous vehicles, infrastructure, and mobility solutions. With that, if you would help me welcome Song Fu.
Thank you. Thank you very much. All right, so really pleasure to be here. So one adding my to give a talk. I don't know what to talk about actually. So I didn't know I want me to talk about the eCAT center. So I prepared the slides. So it's actually more than the center. It's challenges, researchers, and collaborators. And then I saw the email over and over again, like last night. Okay, so Adam wants me to talk about the eCAT center. So now I moved the collaboration before the challenges and research. So now we are going to talk about the eCAT first, and then if we have some extra time, we can talk about the research where we are doing that. All right, so a quick introduction of myself. I think that's probably a lot of stuff in one page. So I am actually a professor in computer science and engineering at UNT. This is my 13th year. I've been here for more than 12 years. So I've been working on several different projects. So currently, it's a site director of the eCAT IUCRC centers. We're working on electric, connected, and autonomous vehicles. So we have done a lot of work on our Tesla car. So this is an EV car with the sensors, LiDAR, camera, radar, GPS, a lot of sensors on it. And also we have done like a lot of work with vehicle computing. So we can do computing not just on the computers, but also on the cars. So there are a lot of deep learning instances running on cars. And also the cars can talk to each other, share their sensor data, and then we call it a collaborative perception. And also the car can talk to edge devices. So, it's kind of infrastructure integrated with the cars. So that's a major part of our work. And also we have done like work for data parts. So one car's sending information to another cars. So probably there are some sensitive information in the images or other messages. So how can we make sure that information is not exposed to other cars? So we're doing a lot of deep learning algorithm designs to protect the private information from that. Another part is for the acceleration. So most of the computation on the vehicle, because the vehicle does not have a lot of resources to do extra work, mission critical applications. So we make the deep learning run faster. Take less resources. So another side of work is on additive manufacturing. So we have a center is called a CAM, so for smart additive manufacturing at UNT. So this is a center sponsored by the Texas government, Texas state, so legislation. So we're doing some machine learning work to process that data to make the additive manufacturing smarter. That's some work we are working on. So quick introduction about the UNT. Probably many of you have heard about UNT or you have been to UNT before. So we are a tier 1 research university, and then this semester we have a record high of the enrollment. Actually, almost 47,000 students at UNT. So it's pretty crowded for the campus. And also the Hispanic Serving Institute, and then offers a lot of programs. So the Department of Computer Science and Engineering, so we are inside of the engineering, the College of Engineering. So we have a total of 14 colleges at UNT. So they're covering a lot of different aspects from art and science to science to engineering to business, a lot of colleges. So we are in actually one of the 5 departments inside of the College of Engineering. And also the largest department in the college. So quick, some members of our department. So it's the largest one. We have about 1,400 undergrad students, 1,800 master students. Big number for us, and then PhD students as well. So we have the BS, the CSCE, and then we introduced cybersecurity 3 years ago. And then we're working on it's called X plus CS. So we have the GIS with CS already. Now we're working with the College of Music. So we'll have like a music plus CS, some other disciplines plus CS as well. So for the masters, we have a master's in AI, cybersecurity, data engineering. So they are pretty new programs. We saw a big enrollment for these new programs.
Professor, so what was X plus CS again?
So X means like other departments, other colleges. Like currently we have a GIS.
Okay.
So it's a Geo Information Science plus CS. So they have other departments, and then they want the student take some computer science courses. So we're working on the music plus CS. We have pretty strong music, the College of Music. So for our computer science and engineering faculty, so this is our areas we're working on. So a lot of more than actually half of the faculty members are working on AI, machine learning, and then we have a brief program for autonomous systems, autonomous vehicles. All right. So when we talk about like the autonomous vehicles, autonomous systems, so actually we have a lot of resources we're developing, or we are currently available for this area. So we have one new institute. It's called Applied AI Institute. So this covers not just the College of Engineering, so the whole university, 14 colleges. So we have a lot of faculty members interested in machine learning, AI. So we are building this new institute. The faculty members from different colleges are working together for AI applications. The second one is a new one. It's the NSF eCAT center. We're going to talk more about it. Okay. And another third one is also new. It's an engine program from NSF. So we are working with 4 universities in Texas and then 2 universities in Oklahoma to build this new engine room with 4 logistics. So it covers AI, logistics, cyber security, different areas. So for the centers we have, it's a CAM center, that's for a SIM center, that's for mobility. And then these 2 new ones. This one is for Geo AI. We got a big grant from the Department of Defense. Probably $4 million for 1 year. We can work for 4 years on the project. Security and then so this is our Discovery Park. Actually, this was a TI building before, and then it's purchased by UNT, and then College of Engineering, College of Information is inside of the Discovery Park. So this one is a newly built. I think it's the corner of the Discovery Park over there. So this is a new testing facility for drones and also autonomous vehicles. Here? Yeah. Yeah. Right. Right. So these are the companies we are currently collaborating with. So for the self-driving car and also autonomous system research project.
And the drone facility, is that on campus?
It's on campus. Yeah. So the inside of this is car park. So it will be ready by November this year. So if you are interested to take tour, to take a visit to the campus, we can show you around. So this car park, all this testing cars and also the testing facilities, they are inside this car park. Yeah, that'd be great. So we're gonna have a big group. It's early December. So probably 20 to 20 people will come to visit us in December. So if you're interested, you're welcome to join us. And also, this is the electric car we have. So equipped with all the sensors, LiDAR cameras, LiDAR radar as well. This is a drone, and then you can test the drone and car inside of the testing facility. Yeah, so probably UT Austin has one, and then we are probably the second one in Texas to have this testing. So anything related to drone, autonomous vehicle communication, and then communication like 5G, we have the 5G routers, also can be accessed on the So we have several industry partners we're working together with, like Toyota. So we have a weekly meeting with Toyota for object perception, and a producer is doing some edge computing for vehicles. So PECA, we have a big program with PECA. It's on the DOE Super Truck 3 project. And then Stage is working on the solar systems and unfortunately 5G routers. Right. So just some configuration of the testing cars. So this is the first generation we had. It's a golf cart. We got donation from the UNT, and then put the sensors on it. And then probably in 2019 we upgraded it to an EV car. So we moved all the sensors to the EV car and then do testing on that. So these are like the computing parts on the car, which are in-vehicle computation computers. So NVIDIA Drive is pretty powerful to connecting all the sensors to the truck to get the communication on. And then this is the autonomous stuff. We use the Spectra, also a pretty powerful computer put it on cars. So there's somewhere like here, we use the battery to power these computing devices on the cars.
How does that computer compare to like what's in a typical Tesla today?
This is more powerful. Yeah, more power. Yeah, more powerful than that. So I can provide the specification. The ARM cores, actually GPU cores as well, pretty powerful, and also it's kind of redundant. So like this is NVIDIA Spectra, NVIDIA Drive. You have two redundant computing systems. If one fails, the other can take over. So this one itself is when we bought it, it's a 15K just for one computer. So if Tesla add that to their car, probably the price will we cannot afford that. Right, and also we have some small cars. This is the one F110. So it's the 1/10 of the real size of the car, but it has like the sensors, LiDAR, 1D LiDAR cameras on it. We can do car-to-car communication and also car-to-drone communication testing. All right, so this is a big picture of what we are working on. So it's called vehicle computing. So we're extending from cloud computing, edge computing, now to vehicle computing. So the computation can be done on the cars. They have their processing power, memory as well. And also the cars can send their sensor data to other cars. Can send images, send like a 3D point clouds to another car, and then if the other car doesn't have like a powerful sensors, we can still use the data to drive. And also this can talk to some other facilities like infrastructure on the streets, and also IoT devices. So we're working a lot with the logistics, so the big trucks get the data from infrastructure and the cars as well. So and then they have like another layer of these edge devices. So, roadside units with small or probably powerful computers, and then they use the cellular communication to talk to them. So this is called vehicle computing. So it's do more computation on the vehicle and also close to the vehicle.
So what RF technology are you using vehicle to vehicle?
So we can use like a 5G cellular.
So that's going not vehicle to vehicle, but
and also probably they can talk to each other directly.
That's what I was saying. What's the RF between direct?
There's a dedicated chip. There's a dedicated spectrum at TC for that.
Yeah. So currently we do not have that testing facility, but we use the campus communication infrastructure to actually. Yeah, but the eCAT is available to test happy to try.
Professor?
Yep.
Who will be building the roadside unit?
So that's a good question.
What was the question?
So who will build the roadside units? Right. So actually, this is a good question. So what we saw is, so they have some communication companies like AT&T, Verizon. So they have the capability for communication. And then those big companies like Google, Amazon, so they have a communication or cloud infrastructure. So then they push you to edge. They have an edge infrastructure as well. But they use the communication companies, their services, to connect the service to the cars. So actually, it's a collaborative work. So this kind of a communication companies, Microsoft, Google, they have a cloud edge, and then collaborate with some communication companies, providing fellow services. And also they have to work with the car companies because they need car information as well. So they're working together to build these roadside units for edge computing or OV. Yeah. So what we saw is like a Microsoft collaborate with some other communication companies to deploy those roadside units.
How many years?
They are deploying currently. They are deploying these roadside units now. So some places we saw the testing site. So the spring break. So one of my colleagues and I visited Hungary. So they are building a new road with all these supercomputers next to the road, and also these roadside units already deployed on the new road.
So they're building this in Hungary?
Yes. Okay. So it surprised us. So for, like in Europe, they spend a lot of money to deploy these sensors, these computers on their new roads. So hopefully we can have I know like there's some corridors in Texas, so where some companies are deploying the sensors as well. So hopefully we can access them there.
Well, Bristol has that need an eye infrastructure in place that works with Audi cars.
Yes, I heard that. Yes. Yes. So and also in addition to that, so we had a meeting with the DOT Texas DOT. So they are telling us like on some of the roads they are deploying the sensors.
We had them present here 2 years ago.
Yeah, we have some collaboration with Frisco. So we heard that we have the smart infrastructure.
Is it part of smart city infrastructure? Is it part of smart city spectrum?
Yes, I think it's part of the smart city infrastructure. So the traffic lights can send signal to the cars. They won't know like before reaching the traffic light. So right. So as I said, we moved the collaboration first, and then if we have extra time, we can talk about research. Probably that's the boring part. So this is a new standard. It's called eCAT. So it's not a real cat. It's not an electric cat. It's just an acronym. So it's for electric connected autonomous technologies for mobility. So this is the only one, only center sponsored by NSF for mobility technologies.
Where's Clarkson? Where? What's
Clarkson University?
Yeah. Oh, Clarkson is in New York. So Delaware, Clarkson, Wayne State. So Wayne State is in Detroit. Right. So probably you may heard of the IUCRC before. So this is like how it runs. One big picture to show how it works. So we have the center, including several universities. So currently 4 universities. The UNT in Dallas, Fort Worth, Wayne State in Detroit, Clarkson in New York. So there are the 3 sites we have. And then University of Delaware is affiliate site of Wayne State. So they are going to submit a proposal in December this year and then join the center. And also the Virginia Tech will submit a proposal. So hopefully Virginia Tech can join us like before the end of the year. So we are working with industry to define the problems. So industry we have IEEE, so they have the advisory board for us. So they'll tell us like what are their interests in their project in the conference, and then they're going to have a list of the topics that they're interested in, and then we university works with industry to define what are the hot topics. We may ask our faculty members to work on, and then we can find projects. So this is kind of a joint work, not just like a university find the problems. Actually, industry will find the problems, and then we are finding the people, the talents to work on this project. And then the center will be sponsored by National Science Foundation. So they give us the fund to support the running of the center. So every year, for each site, they will give us, I think it's 150K for each site. So we have 3 sites. Total each year is 750K. So to run the center. So this is the money to run the center, not for any project. So the project will be supported by the industry partners. So we will find the problem, and then we work together on the project. So for each topic, there's usually like one center for the topic. So for mobility, connected autonomous vehicles, so eCAT is the only one for the IOCI center sponsored by NSF. So if other university wants to work on it, they're going to join the center. So I know like one professor at the UTD, they're interested in joining the center. So we're working with the professor to bring some topics to us. Another like attractive for the center is, so most of the funds from industry will be used to support projects. So like usually we have the overhead is probably 50% as the overhead. So if you have a funded research, then the university will take 50% of the fund as the overhead. But for the center, so the total overhead is about like 10% or less. So 90% of the fund will be given to the team to work on the project. So it's a big plus for if we want to support more students, more personnel to work on the project, and then we have to work on the project. And also, so for all the members in the center, so we have the IEB, so in the Industry Advisory Board, so they will oversee the research of the center. So they can give us suggestions. So what is the kind of interest topic you should follow? So they define the research roadmap for the center. Actually, the industry will define the topic or the research direction. Right. So this is the vision of the eCAT. So we are building the high quality collaboration between the university and industry to define problems for mobility. And then we're going to have a breakthrough of the major challenges we saw for these areas. And then we can apply the technologies to real problems and then real systems. So that's the main goal of the thing. So this is the current trend we're seeing. So traditionally, we're focusing on the hardware, and now we are more focusing on the software. They call it software-defined vehicle. So you have all the hardware available, and then the functions you can add to the car is defined by the software. So probably can see a lot of updates to your electric cars. So each update you have to actually add more functions you can provide to the vehicles. So this is called software-defined vehicles. So a lot of companies are working on that. So GM, Ford, so they are all working on software-defined vehicles. So the hardware is there, but what functions we can provide on top of the hardware? So we have the software outputs. So the center, actually, we've worked on the center for 2 years already. So the first is the planning phase, 1 year planning phase. We have the planning workshop. There's probably like 20, 30 companies join the planning workshop. So they expect the interest to join the center. And then the kickoff meeting actually is the last Friday with the help in Detroit. So it's very successful. We have I think it's probably 20 companies join the first kickoff meeting.
Wow. You have a list of the companies?
Yes, we have on the website. I'll show you later. Yeah, so this is a picture of the workshop, the first kickoff meeting. So total, we have probably 60 attended in person, and then 10 attended on like a remotely, and then more than 20 companies. So there are sending their representatives to attend the meeting to have a discussion about the project. So this is the NSF Program Director, Dr. Bokhan Kumar. So he gave all the attendees a brief introduction of what is IUCRC standards. And then, so we have a lot of projects presented during the meeting. So because this is the first kickoff meeting, so all the projects are new projects. And then the industry partners ask questions about the projects. And then after the presentation, they have a closed-door like IB meeting, just the industry people meet together. So they give a vote to the projects presented, and then select the projects for funding. So all the university people, they are not allowed. We are not allowed to attend the IB. So that's only for industry partners. They are in the IB. The voting, the selection are done by IB. Yeah, so the first phase actually is for 5 years, from this year, like in March, mid-March this year, 2023, to 2028. So 5 years for the first phase. So, and after the first phase, we have the phase 2, that's another 5 years. We have like 10 years for the center. So we focus on like 4 major parts: so electric, so battery design, electric EV cars, and then autonomous vehicles, and then infrastructure like edge vehicle communication, and then smart infrastructure. So all the 3 universities, we have the different focuses. So for us at UNT, we have a pretty strong expertise like in machine learning, AI, and then we have signal processing, the radar, and also LiDAR data. So yeah, for the stage, actually, they're working on battery design. They have 3 projects all working on battery design. Hudson, or it's like a HD map, some other answers. So for the member of the center, actually, the company can access everything, not just like the resources at the UNT, but the resources at other universities, like the students, faculty, all the facilities we have in the center. So one industry member can access everything. Right, so some of the topics we have, actually this is not just a complete list, so we have just some list of the topics that we're working on. Again, so the research roadmap is defined by industry, by our partners from companies. So anything related to autonomous vehicles, EV, CV, CAV, and also machine learning in general, data science, data analytics, and also like cybersecurity, anything related to mobility, we are working on. So if you have some needs in your company and then you want some, like the people in the university to work on, and then we're happy to dive with it.
Who's focused on security of the universities?
We have people working on security. So we have a big program for cybersecurity. So, the CAV, the connected vehicle, and also the canvas as well. So all these are the topics that we're working on.
Okay. That's going to be a big problem.
Yes, that's it. That is. So we have some deployments like the sensors to the canvas, and then like how to protect the messages between the computer units on the canvas. One thing is, so in addition to logistics, also for disabled people, it's actually mobility can provide support. So we're working with like the state of Michigan to help disabled people to go around by using like autonomous vehicles. So these are the resources we can provide for the industry members, like the students, faculty, their talents we have. So students can work on the project. And usually the cost will be lower than the employees at the companies working on that. And the students can be the intern during the summer, regular semesters, and also after graduation, the student can join the company. They are working. Also, we have currently we have 9 members in the center, so 9 companies in the center. So new members can talk with them in an IED meeting, in their regular meetings, so they can have a connection with the people.
Who are the 9 companies who are the center?
So we have a list on the website.
Okay.
So I can show the website.
Okay.
So we have companies working on the storage system for cars. So also some companies working on the battery design, so EV cars. So Ford wants to join us. Actually, we have the connection with the Ford Motor, so they want to join us. And also, what is the other one? Western Digital is one of the center. Yeah, so they're working on the storage systems for vehicle for the edge systems. Yep. So if you're interested in like mobility technologies and then you have some issues, problems that you want to work us to address, then please contact us. We're eager to collaborate with you. Okay, so one more thing is this is also part of our efforts to for the mobility technologies. So this call is the IEEE MOSA conference. It's the Mobility for Operation Services and Technologies. So this is the only conference for IEEE on mobility. So last year's in Detroit, this year, actually, this year's in Detroit, next year will be in Dallas. So I'm the program director, I'm the program chair for the conference. And also my colleagues are the general chair. So we are grouping program committees and also soliciting for high quality papers for the conference. So if you're interested in like joining our program committee, we're welcome to join us. And also if you have any like work you want to publish, you want to submit it to this conference, yes, so this is the deadline for the submissions. And also we're looking for sponsorship. So, if your company like doing mobility work and then can sponsor the conference, so we're going to give you some like a space for you to present your service or products at the conference. And also we are going to add your logos to the conference website. So if you are interested to sponsor this conference, you're most welcome to.
Where do you think it'll be held?
So we're looking at places. So one is like a Frisco. We have a Frisco campus. Another part is like is in Denton. So we have a lot of facilities over there. But
You're gonna have it on campus.
and actually, it's open now. So we're looking at places.
So you're looking at hotels and conference centers now.
Yes, we can do that. But if we have other places like Richardson, or if it's good, then we can also have over here too. So or downtown Dallas.
What do you have in Frisco, you said?
So we have a Frisco campus. So we have called a new college. UNT.
Yeah, I'm across the street from it. I didn't know.
Oh, okay, really?
So you have, what is it you have there?
100 students.
We have more than that. We have more than that. Actually, it's a new college. So we have several programs, and then they have instructors over there. And then we have a pretty large building on the Frisco campus. So they have classes over there, and also
Is it for electrical engineering and like the mobility engineering?
It's not for one college. So like computer science has computer science and engineering work over there, algebra business, computer science. So it's kind of a interdisciplinary areas for different programs like being there. And then we are talking to them to hold a event like next Friday. So it's called a AI symposium for the North Texas. So we invite the faculty members, 4 universities like UNT, UTD, UTA, SMU, all going there next Friday. So to talk about like research for AI applications. So currently we have more than 150 people registered. So that will be like a new center for AI and also autonomous vehicle technologies for us. Yeah. So if you're close by, then
Yeah, my
welcome
office is,
to.
I'm in the whole office part.
Oh, okay.
Right across the street. The building just to the east.
Oh, nice. Yeah, we're thinking about like having this conference in the Frisco campus. Right, probably the next, just close to your office.
Yeah.
The only problem is like there's no hotel in a walking distance.
It's the Autumn. They're right at the start.
The log walk.
And actually, there's several now. And then right across the highway.
Okay.
There's several there. Like 5 hotels. There's a conference.
Yeah, probably like 2 miles to 3 miles. Right?
No, one to 1.5. I can tell you exactly.
Oh, really?
But I'll show you after.
Okay, that's good. That's good enough.
Yeah.
Yeah, we saw the Google map. It's like not in walking distance. Okay.
And then you can use your autonomous vehicles to pick them up.
Oh, there you go.
Exactly. Exactly.
And we used to have 2 years ago or 3 years ago, there was a company that had autonomous vehicles that used to take us. We could order the car.
Yeah.
Yeah.
Get Sean to do it.
Yeah, I had to test it right on that.
Yeah.
We get Sean to do it.
Yeah, we'll get Mosey to go set up operations up there. Get Sean.
Okay, so I'll talk to you.
Yeah, sure.
Thank you for the information. Solve a big problem for us.
He's up that way too.
Is it?
So that's the website, and then so the program, we have some program committee. That's the planning phase now. So you're welcome to join the program committee, and then for the companies, if you can provide the sponsorship. So we're going to highlight your companies during conference. So this is international conference. So people not just from US, but also from Europe, they'll all come to this conference. So there's only one in. All right. Any questions for like the eCAT Center or opportunities we have? No. No. Okay. So how much time do we have?
Till
I got time for Q&A.
yeah, till 12:50.
Oh, 50. Okay.
Yeah, so you got another 15-20 minutes.
Okay. I will not touch the.
This is a very technical group too, so if you want to dig into some of the technology you're involved in, I think we would really enjoy it.
Okay. Okay. I'll go there.
Can't get too technical. for us.
Exactly. All right, guys.
Sure you can.
Ask some good questions.
All right. So then we can have some time to talk about our the car cooperation. So yeah, one thing I just mentioned is like this is kind of evolution of the vehicles. We have the hardware focused to software focused. So all these kind of the new functions of the car actually we can do over the air update, and then we can add more functions later on. So quick introduction about autonomous vehicles. So these are the major components of autonomous vehicles. The sensors, perception system, the landing part, and then the control. So that's the 4 major parts. Sensors provide the data from the road and also data from the infrastructure. And then the main function is to do the localization, so know where the car is. And another part is to perceive the environment, so whether there's any object around the car. So this information will be used for planning. So where should we go, or which open areas I can move the car to. All this will be sent to the control system of the cars, and then you can move the car around. So we need to have a model for the vehicle because each car is different. So the control signals will be adapted based on the data from the vehicles. How we can control the car.
Quick question. This the data going to the sensing it should, in some cases, it's actually going both ways, right? Because the infrastructure is also making changes based on what it's seeing.
Right. So yeah, the data was for the eco vehicle, that's for single vehicle. So that data will be used for the control of the vehicle. And then for the infrastructure for other vehicles, of course, the data can be shared to others. And then other cars can like see longer distance areas that is blocked by other cars. And also the infrastructure can help surround the environment as well. So also the infrastructure can send the data to the vehicle as well, so that they can see, the vehicle can see other places that they cannot see using their own sensors. So this is kind of a tool. Right, so if you go deeper, and then, so how these sensors are used, the sensor data are used, so I have different functions, latency, object detection, distance detection, localization. So these are the major functions the autonomous vehicle need to provide. Of course, they need the data from sensors, right? So how these sensor data are used. So they are actually have a different usage for functions. Like the camera 2D images, so they can be used for lane detection, traffic sign detection, object detection as well. And then for the LiDAR, it's point clouds, right? So we cannot use it to detect the lanes, detect like the traffic sign, but we can use it to detect the object. Right?
They're using LiDAR maps, though.
Oh yeah, LiDAR maps. Yes.
Yeah.
Sorry about that.
So you can't use LiDAR for what?
So for the traffic light or traffic sign detection, right, we cannot do that because it's just the points. So we don't know what is on that traffic sign.
Doesn't read the sign.
Right. Yeah, you have to
Just
read
reads there is a sign, doesn't read the context.
So you can see like there's a sign, but don't know what that sign is. And also the points for the LiDAR point cloud is pretty sparse. So if it's a small object, usually you don't have a lot of points. You can use it for detection. So usually we combine this with sensor data together for activity.
So the main use case of LiDAR is which of the perspectives?
LiDAR is mainly for object detection. So we can detect another car or it's kind of moving person on the street.
Of course, it would also do free space because obviously it's not seeing anything, it would be free space.
Right. Free space.
What they're currently doing now is they're making LiDAR maps and then feeding the LiDAR maps in and looking for deltas on the car between the LiDAR maps.
Yeah.
So it detects like the edges of the road and signs and obstructions. And
It uses a lot of data. Yeah, right. And it's faster.
Yes, another one is for localization. So even though you don't have the GPS, you can still use the LiDAR to know where your car is. So you have the HD map data loaded onto your car, and then you use your current LiDAR point clouds to match like where this car is on the HD map. So even though you don't have the GPS sensor, that's fine. Right.
so the problem is the LiDAR maps are only highways at the moment.
Right. Yes.
GM Super Cruise.
That's what I've got.
Yeah.
How come I'm still so scared on the Tesla?
It should be.
You should be. You should be very
You
serious.
don't have the
Very
LiDAR.
scared.
That it doesn't have LiDAR.
They don't have LiDAR.
Or radar.
Yeah, or radar. They used to have, but it's removed.
They should be scared to any phones that go autonomous.
I like it. It's fun.
It's fun, but man, they have not gotten it where it needs to be yet.
The issue is not the autonomous vehicle. It is the need for an autonomous vehicle to coexist with human-driven vehicles. If all the vehicles in the road were autonomous vehicles, you would be fine.
Right.
The problem is you have to coexist with human drivers.
But
I
I'm
don't know
not
what they're going to do.
I'm not getting rid of my 650i convertible.
No, but I'm not saying that's going to take a very long time.
Very long time.
It's a long way. So that's why like our center can work at least for 10 years, right, or more.
20, 30.
Yeah. So this is for perception. You want to know like the surrounding, what's your road condition or something. And then that information will be used for the plan. Long range route planning, or it's just even immediate like your behavior plan. That's the planning part. So all this will be used to generate commands to control the car.
For localization, how are you going to use it? GPS sensor or any other sensors?
Yeah, for So GPS sensor is for localization, and also the LiDAR can use for localization. You have the HD map, and then just match your LiDAR data with the HD map and know where your car on HD map. But if you have the GPS, but for GPS accuracy is not quite good. So there are probably several meters of error for the GPS.
Right.
You need-
GPS system.
You get millimeters of accuracy with radar and LiDAR.
There are different sensors such as IMU sensor.
Yeah, IMU sensors as well. So I probably didn't put it here. Others, IMU sensors. So it's the movement of the cars, IMU sensor can be used for that. Right. So we talk a lot about like AI. So AI is almost everywhere. So all the major functions for the cars, actually we can have like machine learning model for that. So especially for the perception models, we're working on deep learning network, so convolution neural network, to detect the objects from images, from the 3D point clouds, and also from the radar data as well. So actually we can combine this data.
Can I ask a question?
Sure.
AI and ML. I've been around a few years.
Yeah.
No.
No.
And AI and machine learning goes back way back, okay, tens of years, decades. And when you go chase the current books, you really don't see much. You see a lot of verbiage and discussion. You don't see a lot of technology advances. It's just the same old math adapted for this, for that. Do you agree with that? And what's new about this that hasn't been done?
Yes and no. So yes and no. So
Okay.
yes, it's a old technology. No is like now they're kind of a deeper. So actually, you just feed a big amount of data, and then it can extract all the features by itself.
So what you're saying is probably algorithmic wise, and even somewhat algorithmic wise is where it is. What's really happening is we're getting the hardware that can put it together better and do the computations better. Is that kind of what you're saying?
Not really, actually. So for convolutional neural network, it's kind of similar to the one before. It does not generate some new information. So just like detect the objects on the data you have, we provide. But for some new ones, like the big model transformers and also generative AI, so they are actually generating some new data. So one thing we're doing is for adversary network. So we can use it to find some information that is not available in the current. Like one object is blocked by another object. And we can use the generative AI to recover this blocked areas. So that is different from the previous and also for the attacks. So we can use the generative neural network to generate a lot of adversary images, and then we can make the machine learning model more robust. Yeah, so this part
You can actually use GANs.
Yeah, that's a GAN.
To get the fake images and try and see how it reacts.
Yeah, exactly. We use a GAN to recover some parts blocked by other objects. This is a big topic, so we can probably spend one day or 1 week on that. So at UNT, we're working on actually a lot of different topics. So the vehicle to vehicle, so eagle vehicle, multiple vehicles, vehicle with infrastructure, and then the data privacy. So of course, data privacy is like communication between vehicles. And another one we're working on is actually for the GPT one. So actually, you use ChatGPT, right? So you provide your data to ChatGPT, OpenAI. Actually, your data is saved on the server of the OpenAI, right? Right. So they have like all your like input data over there. So if that server is hacked, so what you provided over there is actually seen by any others. Right. So what we're doing here is, so we're making the GPT network secure. So all the data you provided actually is not the real data. It's a shared secret. So it's a secret. It's encrypted. And then the server on the OpenAI they cannot see your original text. So even if a hack is to just run the data they have defined. But that secret share actually can be processed by our secure GPT network. So we can still get the correct answer, but the OpenAI server does not have a copy of your original text. So that's actually we extend our privacy preserving deep neural network to the GPT network.
So could, in the event of an accident, could they reconstruct by getting the data from your server?
The current one, yes, because all your data is saved on the OpenAI server, so I can see everything.
But in the privacy model, would that be possible?
So the server cannot see your data. So what do you type from your computer? It cannot see anything. Just the encrypted messages. So if they save a copy of the encrypted messages, then they can just run the network again, our network again, to generate output. But what's inside the data, they cannot see it.
Okay, so they can generate and get the data, to get the output.
Yes. Okay. So output is also combined from the output from multiple servers, not just the one. You can just see one output. The output from one server doesn't give you the whole answer. I have only 1 minute.
Yeah. And that's fine. You finish out with this topic here, and
just this page. Great. So what do we do? So this is what we're working with Toyota. So we do some. It's called a multi-car data sharing, and it's a collaborative perception. So traditionally, there's no collaboration. So just a single Eagle vehicle, and then you get all the sensors, and then they extract the features, and then go to the detection network and objects. Right. So for the infrastructure, you have a smart camera. Also, you have your own model to process your own data. That's the current approach to process through the perception. There are also some approaches to combine data from multiple sources, from cars, infrastructure, other cars. So this is called a collaborative perception. So based on where we combine the data, we have early collaboration, late collaboration, or intermediate collaboration. So these two are has been there for a long time. So early collaboration means we can combine the data, the raw data, together. So one image, 3 images, combine it together. Or it's a 1-point cloud, 2-point cloud, put that together. So there'll be more points in the point cloud with density and technology. So this is the raw data collaboration, fusion. And then late collaboration is everyone goes through their own net. So you have a detect object, detect objects. We just combine the objects, these objects together. That's called the late collaboration. Just to combine output together. So this combine input together. So actually what we found is for this one, you have to transfer a lot of raw data. So a raw image, raw point clouds. That will take a lot of bandwidth. So for the LiDAR, the data size is bigger. And then this one is not accurate because if neither one of them can detect objects, so by combining output together, still cannot detect objects. So I cannot see it, you cannot see it. Just combine our two outputs together, you still cannot see it. Right? That solves the problem. So what we found here is actually intermediate collaboration. So we're not combining the raw data, but combining the features. So each one of them has their raw data. We through part of the network, the deep learning network, just extract the features. And then we can combine the features together. And then go into the detection network. So we can detect objects, but also we can reduce the size of the data to be shared between each other. This is what we're doing. So it's in between these two. So we have the features first from each one of them, and then we can exchange the feature maps. And do the fusion here and go to the network. So if all of them cannot detect objects, but combine the features together, actually we can detect objects. This is what we're working with Toyota now. So there's some details I cannot see anything, but this is what.
Awesome. Let's give Mr. Song Fu a pain.
Awesome.